A new wrinkle to relative motion that was finally discovered in the 1800s was what Einstein attributed to Ernst Mach in his 1913 letter to the same. It was Mach who theorized that not only was there Bellarmine's and Galileo's geometric relative motion, there also exists a dynamic relative motion wherein the same forces or effects that appeared in the Newtonian model that had the Earth revolving around the Sun also appear in the post-Newtonian model that has the universe rotating around a fixed Earth. Einstein merely borrowed from Mach's dynamic equivalence and put it into his theory of general relativity, at least as best as he could within the constraints of his overall system. Hence, it was also discovered that apart from general relativity and its penchant to create unproven oddities such as black holes, wormholes, time warps, and bent space, the principle of dynamic relative motion could be deduced by a simple combination of Newtonian and Machian mechanics, wherein Newton's laws of motion could then be reformulated by Mach's dynamic principles. Whereas Newton had failed to turn the coin over, Mach's principle not only turned it over, but showed how Newton's whole system could be reconstructed so that Newton's defect, as Einstein termed it, could be fixed and lead us in the right direction. Mach did so by pointing out that it was wrong for Newton to base his whole system on what Newton called absolute space, a space that wasn't allowed to move or rotate and thus forced us to only one option: the Earth rotating within a fixed space. In other words, if Newton's absolute space was made to be non-absolute, that is, that it would be allowed to rotate, and the Earth was the absolute object or center of mass that couldn't move, then the defect in Newton's physics would be cured and science could advance. This advancement in the general principle of relativity, of course, led Einstein right to his theory of general relativity, regardless whether Einstein then extrapolated on the general principle and produced the distinctive oddities of his general relativity theory. In turn, the advancement beyond Newton led other physicists to the same principle of dynamic equivalence, although without adding all the peculiarities that general relativity had produced. For example, the famous late astronomer Fred Hoyle candidly admitted that
we can take either the Earth or the Sun, or any other point for that matter, as the center of the solar system. This is certainly so for the purely kinematical problem of describing the planetary motions. It is also possible to take any point as the center, even in dynamics, although recognition of this freedom of choice had to await the present century.
Other scientists have applied the general relativity principle with mathematical rigor. For example, physicist André Acis, in his 1999 book, Relational Mechanics, shows by using a combination of Newtonian and Machian physics that we can no longer assume that the Earth rotates within a fixed universe, but the reverse is just as viable and likely. He writes,
"The flattened figure of the Earth, or Foucault's pendulum, can no longer be utilized as proofs of the Earth's real rotation." In relational mechanics, both facts can be equally explained, with the frame of distant galaxies at rest exerting a gravitational force on bodies at the Earth's surface, while the Earth rotates relative to this frame, or with the Earth at rest, while the distant galaxies rotate around it, exerting a gravitational force on bodies at the Earth's surface. Both explanations are equally correct and yield the same effects. It then becomes a matter of convenience or of convention to choose the Earth, the distant galaxies, or any other body or frame of reference to be considered at rest.
Physicist Luka Popov said much the same in his seminal paper, Newtonian Machian Analysis of the Neo-Tychonian Model of Planetary Motions, which was published in the European Journal of Physics in 2013. He writes,
"The analysis of planetary motions has been performed in the Newtonian framework with the assumption of Mach's principle. The kinematical equivalence of the Copernican, heliocentric, and the Neo-Tychonian, geocentric systems is shown to be a consequence of the presence of pseudo-potentials in the geocentric system, which, according to Mach, must be regarded as the real potential originating from the fact of the simultaneous acceleration of the universe.
Incidentally, Popov extracts another interesting fact that we will examine later. He writes,
There is another interesting remark that follows from this analysis. If one could put the whole universe in accelerated motion around the Earth, the pseudo-potential corresponding to the pseudo-force will immediately be generated. That same pseudo-potential causes the universe to stay in that very state of motion without any need of exterior forces acting on it.
A third example of this trend in modern physics is found in a recent book by one of today's more famous physicists, Steven Weinberg. He says the same as Asis and Popov, but he also invites Newton to the party. In fact, Weinberg says that we should not be so hard on old Newton, since Newton himself may have had a hint to the principle of dynamic equivalence that he wanted to publish in his last page of his 1687 book, De Principia Mathematica. But for some unknown reason, the page never made it for publication. In his 2015 book, To Explain the World, Weinberg writes,
If we were to adopt a frame of reference like Tycho's, in which the Earth is at rest, then the distant galaxies would seem to be executing circular turns once a year, and in general relativity, this enormous motion would create forces akin to gravitation, which would act on the Sun and planets, and give them the motions of the Tychonic theory. Newton seems to have had a hint of this. In an unpublished Proposition 43 that did not make it into the Principia, Newton acknowledges that Tycho's theory could be true if some other force besides ordinary gravitation acted on the Sun and planets.
Weinberg's reference to forces akin to gravitation refers to the inertial forces, namely the centrifugal, Coriolis, and Euler forces. Using Einstein's general relativity as the basis for his proposal, Weinberg indicates that, in the view of modern physics, a universe rotating around a fixed Earth will create inertial forces that mimic the force of gravity. As the universe's inertial forces meet the gravitational forces in our solar system, in turn, this will allow the Earth to be fixed in the center and for the Sun to revolve around it. Weinberg notes these forces are hinted at in Newton's Proposition 43, the intended last page of the Principia. In Proposition 43, Newton says,
In order for the Earth to be at rest in the center of the system of the Sun, planets, and comets, there is required both universal gravity and another force in addition that acts on all bodies equally according to the quantity of matter in each of them, and is equal and opposite to the accelerative gravity with which the Earth tends to the Sun. Since this force is equal and opposite to its gravity toward the Sun, the Earth can truly remain in equilibrium between these two forces and be at rest. And thus, celestial bodies can move around the Earth at rest, as in the Tychonic system.
As we see, Dr. Newton couldn't be any clearer. If there are forces akin to gravity operating in our universe and solar system, then all the celestial bodies, including the Sun, can move around an Earth at rest in the center of the universe. Few, if any, have ever heard this admission from the pen of Isaac Newton or anyone else. And because of this apparent obscurity, one might think that the information we are presenting here is buried deep in the recesses of physics libraries, and one would have to go on an extended manhunt to locate them. The truth is that these astounding facts are right at our fingertips. All one needs to do is click a few keystrokes to the popular online site, Wikipedia. Under the title Coriolis Force, Wikipedia shows the same mathematics for a geocentric universe that are used by all the aforementioned physicists, including Weinberg's attribution to Newton. First, the Wikipedia authors show us the three inertial forces in their mathematical form that would operate in a geocentric universe. The article begins,
Components of acceleration. To determine the components of acceleration, a general expression is used from the article fictitious force. in which the term in omega cross VB is the Coriolis acceleration, and the term in omega cross RB is the centrifugal acceleration. The results are producing the centrifugal acceleration as follows, which produces a Coriolis acceleration as follows.
The Wikipedia article then makes this pertinent conclusion.
It is seen that the Coriolis acceleration not only cancels the centrifugal acceleration, but together they provide a net centripetal, radically inward component of acceleration that is directed toward the center of rotation.
We see then that the Coriolis force is so strong that it counteracts the centrifugal force and creates a centripetal, inward force on the revolving object. This greater power of the Coriolis force is seen in that it has a 2 before the omega vectors. And since V equals omega cross R, we have 2 omega cross R, showing that the Coriolis force is twice the centrifugal force omega cross R. Wikipedia verifies this force relationship in its article on fictitious forces, saying,
in this case, the Coriolis force is twice the magnitude of the centrifugal force, and it points in the centripetal direction. The vector sum of the centrifugal force and the Coriolis force is the total fictitious force, which in this case points in centripetal direction.
So again, we see that the combination of the centrifugal and Coriolis forces will produce a force in the centripetal direction, which means that the Sun will revolve around the Earth. Before we move on, we should note that when Wikipedia says, quote, the centrifugal and the Coriolis force is the total fictitious force, unquote, the word fictitious refers to how the Newtonian system had originally accounted for the inertial forces on celestial objects. But in the geocentric system, in which the universe is not absolute, but rotates around a fixed Earth, the fictitious forces are not the results on celestial objects, but the actual cause for why the celestial bodies will revolve. In other words, they are real forces, not fictitious forces, and they are caused by the angular momentum of the rotating universe. Physicist Christian Moeller, in his book The General Theory of Relativity, explains what is occurring in more technical terms.
If we consider a purely mechanical system consisting of a number of material particles acted upon by given forces, Newton's fundamental equations of mechanics may be applied with good approximation in the description of the system. On the other hand, if we wish to describe the system in an accelerated system of reference, we must introduce, as is well known, so-called fictitious forces, centrifugal, Coriolis, and Euler forces, which have no connection whatsoever with the physical properties of the mechanical system itself. It was just for this reason that Newton introduced the concept of absolute space, which should represent the system of reference where the laws of nature assume the simplest and most natural form.
In other words, Newton's original laws of motion work when the system is not accelerating. To create this kind of environment, Newton had to have his absolute space that did not move. That is, it did not accelerate. But to compensate for this assumption, Newton had to add in centrifugal and Coriolis effects to account for movements not predicted by his equations. Since in Newton's system these movements had no physical cause, they were called fictitious forces. And Moeller continues,
therefore, Einstein advocated a new interpretation of the fictitious forces in accelerated systems of reference. Instead of regarding them as an expression of a difference in principle between the fundamental equations in uniformly moving and accelerated systems, he considered both kinds of systems of reference to be completely equivalent as regards the form of the fundamental equations. And the fictitious forces were treated as real forces on the same footing as any other force of nature.
In other words, Einstein said that it wasn't right for Newton to assume an absolute space in which his objects could move, and thus it wasn't right to regard the additional centrifugal and Coriolis motions that occurred as fictitious. Obviously, Einstein rejected Newton's absolute space. That being the case, the forces that make the additional movements of objects must be real forces, and thus, in a rotating system, such as the universe rotating around a fixed Earth, the centrifugal and Coriolis forces are real, not fictitious. Einstein then gives the actual reason they are real, since they are caused by mass of the universe that is in rotation.
The reason for the occurrence in accelerated systems of reference of such peculiar forces should, according to this new idea, be sought in the circumstance that the distant masses of fixed stars are accelerated relative to these systems of reference.
Muller then tells us the same thing that Weinberg told us, namely, that the centrifugal and Coriolis forces are akin to a gravitational force and act just like gravity.
The fictitious forces are thus treated as a kind of gravitational force, the acceleration of the distant masses causing a field of gravitation in the system of reference considered. Previously, the effect of the celestial masses had been considered to be negligible. Now, however, we must include the distant masses in the physical systems considered. This is the so-called general principle of relativity.
With these physical laws in the background, we see, as illustrated in the animation, the stronger Coriolis force, the blue arrow, is generated by the rotating universe, and it will keep the Sun in daily tow around the Earth, even though the Sun is more massive than the Earth and is pulled outward by the weaker centrifugal force, the green arrow. In fact, the strength of the universe's Coriolis force will keep all the stars in daily rotation around the universe's central axis. In this way, as noted earlier by Weinberg, the geocentric inertial forces mimic the heliocentric gravitational force. These real inertial forces created by a rotating universe are the same forces that Newton had alluded to in the last page of his Principia Mathematica as the basis for a geocentric system. Unfortunately, Newton didn't know where to find these forces because he never envisioned the universe rotating around a fixed Earth. That knowledge wouldn't come until Mach and Einstein came on the scene 200 years later. In the heliocentric system that Newton used, the centripetal force to keep the Earth revolving around the Sun came from the gravity of the Sun, not the inertial forces from a rotating universe. In Newton's system, the Sun is thus said to put a centripetal force on the Earth and thus counteract the Earth's inertia that seeks to move the Earth in a straight line away from the Sun. The result is that the Earth curves around the Sun as it moves. Today, unfortunately, physicists partial to having the Earth revolve around the Sun for philosophical reasons do so by confining Newton's physics to the solar system and thereby exclude any external forces akin to gravity that would be generated by a rotating universe. Essentially then, to have a geocentric system, all that needs to happen is for the moving Earth to be made fixed and for the fixed universe to be made to move. There is really no great mystery involved. That being said, of the two systems, the geocentric has a distinct advantage over the heliocentric, which we will outline in the following analysis. As we noted earlier, Einstein himself pointed out that there exists an inherent defect in the Newtonian system because of its insistence on having an absolute and immovable space, which, in modern terms, becomes Newton's inertial coordinate system. But as we said, this was assumed by Newton, but never proven. Newton merely assumed the Earth was rotating and the universe was fixed, and he produced his physics accordingly. Newton's inertial coordinate system, his absolute space, allowed him to then claim that the inertia of an object moving in its absolute space will travel in a straight line. The corollary of Newton's proposition, of course, is that if the space in which the object moves is also moving, then it cannot be said that the object is moving in a straight line. It would be moving in a type of curved line. Although space for Newton had to be perfectly fixed, this presented several problems that Newton was never able to explain. The first was that Newton had to assume that an object that moved in space would not only seek to move in a straight line, it also had to have a property that kept it moving, to which he assigned the term inertia. But this supposition only begged the question as to the cause of inertia. In other words, where does a moving body acquire the continual power to keep moving? Giving it terms like inertia or momentum merely labeled the phenomenon, but it did not explain why it occurred. According to Newton, the body would keep moving ad infinitum unless another object or force stopped it from moving. Is this really the way it works, or does the body need some kind of impetus to keep it moving, as Aristotle proposed long ago? This is one of the fundamental questions in physics that is still debated today. The second problem for Newton, and one that we alluded to earlier, was that in dealing with rotating objects or rotating reference frames, Newton's second law, force equals mass times acceleration, would not work, since it couldn't account for the appearance of an additional set of forces that made the object move in an orthogonal direction to the motion in view. As noted earlier, in order to explain the orthogonal motion, Newton would have to add in, by hand, an additional set of forces, which are known as the centrifugal, Coriolis, and Euler forces. He compensated for this addition of forces by calling them fictitious or pseudo-forces, giving the impression that they weren't real forces but only necessary to add when one switched from an inertial frame to an accelerated frame. Even today, in order to send satellites into space, physicists must add in these three inertial forces to Newton's F equals ma. Otherwise, the satellites will not perform correctly. In effect, the final equation used for satellites becomes force equals mass times acceleration plus centrifugal plus Coriolis plus Euler forces. A third problem for Newton was that although his gravitational equation depended on the distance between the masses in the equation F equals mass 1 times mass 2 divided by the radius of their distance squared, this assumed that the force of gravity between the two objects was instantaneous, since his equation includes no factor for reaction time. This meant, of course, that gravity would have to be the fastest known force in the universe. But Newton had no explanation for what even caused gravity, much less how it could travel so fast. Einstein tried to answer the problem by making gravity somewhat of a fictitious force itself. According to Einstein, gravity would occur because massive objects would curve the space around them, which curve would make smaller objects follow the curve toward the more massive object. But this explanation assumed that space was a substance that could be bent, whereas in his special relativity theory, Einstein said that space was empty. Einstein, from his early days, claimed space was a vacuum of nothing. But if it was nothing, then what was bending, since only something can bend? And why did massive objects have the ability to curve space? What attractive force did they have, and where did it come from? Moreover, if space could curve, what was it curving in relation to? What in so-called empty space was first considered straight that we could then say another portion of space was curving against it? In Einstein's day, Paul Heil saw the same problem.
Einstein supposes space itself to be enough of an entity to have a curvature, and to be empty only where and when it is flat. But if space can be bent and can straighten out again, why can it not repeat this process with sufficient rapidity to be called vibration? And what difference does it make whether it is space itself that vibrates or something that fills space? Back in every one of our heads is the idea that there is something which philosophers call a thing in itself, which is responsible for our sensations of light and electricity. And whether we spell it ether or space, what does it matter?
Like Newton, Einstein was forced for lack of knowledge to explain things by referring to their effects rather than uncovering their actual causes. In Einstein's system, relativists like to refer to space as a conglomeration of inertial space-time pockets, but with no explanation as to what constitutes that space, or how the space-time pockets fit into the non-inertial space of Einstein's general relativity theory. Additionally, Einstein had no answer to the assumption that Newton had to make regarding the speed of gravity. Everyone realized that for gravity to work properly, it should be instantaneous, to account for what was otherwise known in physics as the action at a distance problem. But no one could explain how gravity could be instantaneous, especially since Einstein's special relativity had limited the universal speed limit to that of light at 300,000 kilometers per second, claiming in his special relativity theory that nothing in inertial space-time could exceed it, including gravity. Interestingly enough, all of these problems can be solved in a geocentric universe, as we will see later in our lecture. There are a few more things we need to demonstrate. First, as noted by Popov concerning the inertial forces,
if one could put the whole universe in accelerated motion around the Earth, the pseudo-potential corresponding to pseudo-force will immediately be generated. That same pseudo-potential causes the universe to stay in that very state of motion without any need of exterior forces acting on it.
This means that once the universe begins rotating, its conservation of angular momentum will keep it turning ad infinitum. We can easily see then why this kind of system will be the most stable of all systems, since the universe is so large and massive, and thus its momentum to continue rotating is so great. It will, by far, be more stable than a small Earth moving in a large universe if we consider all the internal and external forces that will come against a rotating and revolving Earth to slow it down, such as earthquakes, tsunamis, volcanoes, asteroids, planetary perturbations, solar forces, etc., etc. Second, the mechanics of a rotating universe will show that the Earth will have no inclination to rotate, even though the universe is rotating around it. This is the case because when the gravitational and inertial forces are balanced at the center of mass, which center of mass the Earth will necessarily occupy if the universe rotates around it, they cannot generate a torque on the Earth, and thus the Earth will remain absolutely motionless. As noted by one science reference in Wikipedia,
if the reference point R is chosen so that it is the center of mass, then the resultant torque, T, is zero. Because the resultant torque is zero, the body will move as though it is a particle, with its mass concentrated at the center of mass. By selecting the center of gravity as the reference point for a rigid body, the gravity forces will not cause the body to rotate, which means the weight of the body can be considered to be concentrated at the center of mass.
Additionally, the universal Coriolis force itself also plays a part in helping to keep the Earth stable and non-rotating. Since when the Earth is the universe's center of mass, the Coriolis force will be divided into two distinct directional forces at the Earth's equator. In Earth's northern hemisphere, and by extension the northern hemisphere of the entire universe, the Coriolis force moves in a counterclockwise direction, which is why hurricanes on Earth turn counterclockwise in the north. But the Coriolis force moves clockwise in the southern hemisphere, and thus hurricanes turn clockwise in the south. These two opposing circular directions neutralize each other so that the torque on the Earth is again zero. Moreover, as we noted earlier, that the combination of the stronger Coriolis force and the weaker centrifugal force will produce a net centripetal force, and since these inertial forces are ubiquitous because they are generated by the rotating universe, the result is that centripetal forces are coming in a radial direction towards Earth from each quadrant of the universe. As such, this force also helps keep the Earth from moving. It will be completely at rest. Before we move into our final topic, at this point, we should answer a common objection that often arises when we, or even Einstein, speak of the universe rotating around a fixed Earth. The natural question is, how can the universe rotate so fast? Wouldn't it have to travel many times the speed of light in order to complete its daily task? The answer is certainly affirmative. Beyond the orbit of Saturn, the universe would have to be rotating beyond the speed of light. The reason that many people have this objection is because they have been conditioned by Einstein's first theory, the special theory of relativity, to conclude that nothing can go faster than light. Since this postulate of Einstein's has been so indiscriminately taught and advertised in science documentaries and academic classrooms, everyone believes it would be impossible to exceed the speed of light. But the simple logic is, since Einstein, as we have noted earlier, agreed that his 1915 general relativity theory requires that the universe be able to rotate daily around a fixed Earth, then obviously Einstein had to modify what he said in his special relativity theory about the limits on the speed of light and material objects. In fact, Einstein had to modify almost everything he claimed in his special theory when he invented his general theory. We already saw, for example, that in his general theory, Einstein took back the very ether that he had denied in his special theory, which again is a well-guarded secret in academia today. But the same is true with the speed issue. Whereas the special theory insisted that the speed of light was constant and could never exceed a determined limit, the general theory said the speed of light is not constant and can exceed far beyond the limit given in the special theory. Let's hear this from Einstein himself. He writes in the same book,
In the second place, our result shows that according to the general theory of relativity, the law of the constancy of the velocity of light in vacuo, which constitutes one of the two fundamental assumptions in the special theory of relativity, and to which we have already frequently referred, cannot claim any unlimited validity.
Additionally, whereas the special theory insisted that objects of mass could not exceed the speed of light, the general theory held that any object can travel at any speed, at light speed or even beyond light speed. If all this is true, doesn't the general theory contradict the special theory? Call it what you will, a modification, an adjustment, a rearrangement, or a contradiction. The results are the same.
Speed of light is constant, but in general relativity, no, it's not.
Special relativity was created to deny geocentrism and interpretation of Michelson-Morley. The special relativity led to general relativity, and general relativity supports geocentrism.
Now, is that a contradiction? No, in the wonderful world of mainstream, if you find an experiment where speed of light is constant, then you say, oh, special relativity applies. If you find where it is not constant, you say general relativity applies.
Albert Einstein himself said that if Michelson-Morley is wrong, then relativity is wrong.
If one day God comes down from above and says, look, these two great theories, relativity and the quantum theory, are wrong, what would I say? First of all, I would say, oh my God, all my published works are wrong. I mean, I'll have to look for another job.
And I've heard people say that the reason they don't want to publish papers that disagree with special relativity or general relativity is that they built their careers on this, and that it would be admitting a major mistake.
Okay, I'll be on the unemployment line, okay? But second of all, once I collect my wits, I would simply say, but of course. You see, we are approaching truth, but can you actually get to absolute truth?
If you were paranoid, you'd say there's a conspiracy. Whatever it is, there is a lot of resistance to getting something published that disagrees.
We must
with
remember that
either
Einstein was
Einstein.
originally forced to claim that the speed of light was constant in his special theory, otherwise he would have had no answer to Michelson's 1887 experiment that showed the Earth wasn't moving in space. Essentially, either Einstein made light constant or he would have to make the Earth constant. But to make the Earth constant would mean that physics had been fundamentally wrong to its very core for the last 500 years since the Copernican revolution. So, to preserve the Copernican principle, Einstein felt philosophically compelled to choose light as the constant instead of the Earth. In doing so, he found a temporary relief from having to admit that the Earth was the only object not moving, and thus is the universe's only true constant. But this relief was certainly fleeting. Einstein knew his special theory was not only inadequate but also inapplicable, since in a universe that had the ubiquitous forces of gravity and inertia, and could also rotate if needed, could never contain the pristine inertial frames of reference required by special relativity. Consequently, though Einstein never planned for this to happen, to his consternation, what he denied to nature in his special theory suddenly became allowable in his general theory. As noted relativist William G.V. Rosser puts it,
if gravitational fields are present, the velocities of either material bodies or of light can assume any numerical value, depending on the strength of the gravitational field. If one considers the rotating roundabout, Earth, as being at rest, the centrifugal gravitational field assumes enormous values at large distances, and it is consistent with the theory of general relativity for the velocities of distant bodies to exceed the speed of light at 3 × 10⁸ meters per second under these conditions.
Notice what Rosser is saying. He is describing a geocentric universe in which the Earth is at rest in the center and the universe is rotating around it. As we can see, the geocentric system is required both by the general principle of relativity and Einstein's general relativity theory. There is no escape from it. And in that kind of universe, light and material objects can vastly exceed the terrestrial speed of light that we know on Earth as 3 × 10⁸ meters per second. The world's greatest scientists have admitted it. There is no argument. The only other thing that most of them have agreed to is that they will try to keep it to themselves and hide it from the layman, like you. What we have with a rotating universe is an environment without limits and without absolutes, except the limits imposed by the various forces of nature on themselves. As such, electricity will limit magnetism and magnetism electricity, and gravity and inertial forces will limit them both, and the ether will be the conduit and functionary for all of them. The only absolute will be the fixed Earth, which will then allow us to make accurate measurements of all the forces in the universe and their effects. In a word, once we have an absolute, such as a fixed Earth, that cannot be de-absolutized, we have the only firm foundation upon which science can build itself.